Hello everyone. Today we will see the Mohr circle. What are the importance of Mohr circle? How to evaluate normal, tangential, shear stress by using graphical method. In previous videos, we learned how to evaluate normal stress, principal stresses, maximum shear stresses, resultant stresses, position of resultant stresses, position of shear stress, position of principal stresses that we have evaluated analytically. Today we will see there is one graphical method which is known as Mohr circle method, through which we can evaluate these all the parameter, that is maximum principal shear stress, maximum shear stress, and all. So let's start. This Mohr circle is used to evaluate in different three conditions: when two forces are acting on a body, there is two mutually like direct stresses acting on a body, then we can use the Mohr circles. Second one, two mutually unlike, means one is tensile, one is compressive, direct stresses acting on a body. So in that case also we can use a Mohr circle. And third is a body subjected to two mutually perpendicular principal tensile stresses accomplished accompanied by a simple shear stress. So if you observe analytically, these two were our case number 2, that is a body subjected to two mutually perpendicular principal tensile stresses, and this was nothing but this is a case number 4th. Here we evaluated normal shear stresses, principal shear stresses. So let's start to analyze with graphical method. So first I will consider the first method. So here if we consider a bar, and this bar is subjected to two mutually perpendicular stresses. So here I will consider sigma x along x direction, sigma y along y direction. Clear? So if such case is there, how to evaluate principal stresses and shear stresses? Let's try to understand. So first I will consider a point. Now whatever the magnitude is there, let's say sigma x is 100 Newton per mm square and sigma y is 70 Newton per mm square. Now convert these values 100 Newton per mm square in suitable scale. So if I consider 1 centimeter equal to 10 Newton per mm square, then for sigma x I will draw 10, 1 centimeter is equal to 10, so 10 centimeter line. So consider any one point. From that point, draw a line. So mark that point as B point. So this is 10 centimeter line. Next, so along x-axis we are going to mark only normal stresses. So next is sigma y. Sigma y is 70 Newton per mm square. So that is equal to 7 centimeter. So from same point mark the line. So here I will consider that point is C point. Clear? Now when we consider this dimension, then take CB as a diameter. We have marked two normal process. This is sigma x and this AC is nothing but sigma y. So here consider BC as a diameter and draw one circle. So here I will consider the center point. I will draw a circle. So here if you observe, the circle is passing from both the point. So this is B point and here C. Clear? Now after that consider 2 theta and draw one line from this x-axis. Consider 2 theta. So this angle is 2 theta. Mark that point E. From this E drop one vertical line. So mark this point as D point. This is O point. So if you observe this ED, it will give you the shear stress value. Clear? And from A to D, this will give you the normal stress acting on a body, and this is tangential stresses acting on a body. If you join this A to E, this line gives the resultant stress. How to evaluate angle of obliquity? As we know, this is an angle between the normal stresses and the resultant stresses. So normal stresses is given by the line AD. So here angle is nothing but phi. If you join this C with E, and then here you will get the angle theta. Clear? Now you may ask me, sir, how you have taken this 2 theta? Why 2 theta, not theta, not 3 theta? So let's explain that also. Why this AC is over here? So all things I will explain over here. Same diagram is there. I have redrawn over here. This is our sigma x, sigma y. I have marked along this horizontal line, and here I will get the ED as a shear stress. So from this diagram, if you observe AD, distance A to D, this is nothing but normal stress acting on oblique plane. ED, this ED along y direction, if you measure, that is nothing but it's a resultant, tangential stresses. Now if I ask you what will be the maximum shear stress, then I can say that this OE, when it becomes fully vertical. So from this, if I drop a line up to this, so if I consider this H point, then OH is nothing but a radius of circle, and this will give you the maximum shear stress. Clear? So this OH will be the maximum shear stress value. or it means radius of the circle. So as we seen, sigma x minus sigma y divided by 2, that will be the radius of circle. Clear? So how to mark, why to mark this 2 theta? Let's understand by analytical method. So just we will recheck whether the things are correct or not. Now here I will write proof for this Mohr circle method. So first I will write the radius of circle, that is CO, equal to OB, that is equal to OE, that is again equal to OH. So that will remain same, that is sigma x minus sigma y divided by 2. Now here I have considered both the like stresses. Like means all I have considered tensile. That's why from A I am considering in positive direction, in right direction. Clear? So this is an radius. So you will get sigma x minus sigma y divided by 2. Now if I want to evaluate A to O, so how can I write AO? That will be the AC plus CO. So what about AC? AC is nothing but it's a sigma y. So here I can write sigma y plus CO. CO I have evaluated over here, sigma x minus sigma y divided by 2. So if I take 2 common, then it will become 2 sigma y plus sigma x minus sigma y. So from 2 sigma y minus y, here I will get sigma x plus sigma y divided by 2. Clear? So this is our first expression for AO. Next I want to evaluate this OD. How to evaluate this OD? It's simple. If you observe this triangle OED, so if you observe this triangle OED, so as this is 2 theta, then I can write for OD equal to OE into cos of 2 theta, cos of 2 theta. So OE, so this is OE into cos of 2 theta. So here I got the OD. Now what I want, what I am saying, A to D is a normal stress. So A to D, so I can write AO plus OD. Now if you observe this OE, what is OE? Again radius of circle. So that is sigma x minus sigma y divided by 2 into cos of 2 theta. Now from these two equations, so equation 1 and equation 2, if I put the value for AO and OD, then I will get AD equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos of 2 theta. Clear? And if you observe, this is the normal stress. This is the value for normal stress. So that is why the length AD multiplied by scale, it will give you the normal stress acting on that particular body. Clear? Similarly, if we observe this ED, I am considering ED as a tangential stress. Clear? So if I write for ED, then it is equal to OE into sine of 2 theta. So again from this triangle, sine of 2 theta equal to ED divided by OE. So what is OE? OE is nothing but radius of circle. So sigma x minus sigma y divided by 2 into sine of 2 theta. So this equation is nothing but sigma t, that is tangential stress acting on a oblique plane. So from this equation 3 and 4, I can say that this graphical method is used to evaluate the tangential stress and normal stress acting on any body. Now if I ask you the shear stress maximum, that will be equal to sigma x minus sigma y divided by 2, and it is given by OH. So here OH, if you measure this OH, it is nothing but it's a radius again, and radius is given by sigma x minus sigma y divided by 2. So this is the method to evaluate the normal and tangential stresses acting on a body. If you measure resultant stress AE and if you multiply by the scale, then you will get the resultant stress also. So this is the proof between the graphical method as well as uh, analytical method. Now let's consider the next case. So that is if two if two unlike mutually perpendicular stresses acting on a bar. So means one force is compressive and one force is tensile. So at that time, what will the procedure? So let's say sigma x is 100 Newton per mm square. It's a positive, or we can say it's a tensile. And if I consider sigma y, that is minus 70 Newton per mm square, negative, so I can consider this as a compressive. Both are unlike forces acting and subjected to on a bar. Then how to evaluate normal stress, shear stress, principal stresses on an oblique body? Then the procedure will start with the point A. As sigma x is a positive, so I will consider in right direction. So this will be the point B, sigma x. Now sigma y is in negative direction, so I will consider sigma y in left side. So here I will consider C. Now the thing is, we need to consider this CB as a diameter and O as a center point. We need to draw a circle. So let's draw a circle which is passing through the point B and C. So here, what is changed in previous and over here? If the forces acting on the bar, if it is a tensile, then take it in positive side, and if it is compressive, then take it in negative side in left direction. So CB as a diameter, draw one circle. From O as a center, draw one line at an angle of 2 theta. So now you might have got the point why 2 theta, because in this formula if you observe it is a cos 2 theta and here O equal to sin 2 theta. That's why I am considering 2 theta. So here I will get the point E. If you drop a point over here, clear? If you drop a point from E, then here I will get the point D. So this ED, it will give you the tangential shear stress. So this, if you measure this length and if you multiply by scale, then that will be the tangential shear stress. And this AD, if you measure, this will give you the normal shear stress. And if I join this A with E, A with E, then this will be the resultant shear stress and the angle between resultant and normal. So this is nothing but it's a normal shear stress, and this angle it will give you the angle of obliquity. If you join this C point with the E point, then this will be the angle theta. Clear? So what is the difference? If it is compressive force is compressive stress is acting on a body, then take in negative side. If tensile stress is acting, take it in positive side. That's it. Remaining thing is common as we learned in previous case also. So from this diagram, if I consider AD, so that is the normal stress on oblique body, AD. Next is ED. If you measure length ED and multiply by scale, then it is nothing but it's a shear stress on oblique body. And if you measure the length AE, that will be nothing but it's a resultant stress on oblique body. So if I ask you radius of this Mohr circle, then if I consider the CO or OB, then that will be the sigma x plus sigma y divided by 2. If you use same analytical method, then you will get the same formulas, only there will be a negative sign. Instead of this positive, you will get negative. Instead of this negative, you will get the positive. That's it. As we already learned and how to evaluate the mm, uh, normal stress and tangential stresses on the body, then we use these two formulas. Only when there is a compressive stress, then instead of positive, here we consider the negative. Clear? So same thing will be there. So if I ask you, then normal stress acting on body, then sigma x plus minus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos of 2 theta, and tangential shear stress, that will be equal to sigma x minus sigma y minus into 2 into sine of 2 theta. So these two equations are valid for this particular case, in which one stress is tensile, another stress is compressive. Clear? So this is second case. For that we can use the Mohr circle. Now let's see the last case where we can use the Mohr circle, that is when a body subjected to two mutually perpendicular principal stresses accompanied by a simple shear stress. So previously we were using only sigma x, sigma y. Now here we will consider shear stress tau also. Clear? So let's say the value sigma x 100, sigma y 70 Newton per mm square, Newton per mm square. I am considering both are tensile. Now here I am considering shear stress 40 Newton per mm square. Now same scale I will use. Let's start construction of Mohr circle. Now first consider any point A. From this point mark sigma x and sigma y by taking suitable scale. So I will draw sigma x 10 centimeter. So I will mark that point is B. Next I will mark sigma y. So 70 is given. So here I will mark the point C. So this was the previous case, and here we were considering CB as a diameter and we were drawn the circle. Now the case is different. Now here we are going to consider the tau. So when shear stress is given, in that case, as we know that on horizontal direction we are taking principal stresses, and on vertical direction we are taking the shear stresses simply. So here from C I will draw a shear stress having 40 Newton per mm square. Again from B I will draw a shear stress of 40. Then join these 2 points. Let's say this is G and let's say this is F point. Join these 2 points. Now wherever it will intersect, this point will be the O point. Consider GF. Now we are not going to consider CB as a diameter. Consider GF as diameter, O as center. Draw one circle. So try to understand, it's a circle. Clear? So I will extend this line. Let's say this point is M point. So let's consider this is circle. I know this is not circle, but try to understand. And this circle is passing from this G point and F point. Clear? Now again from this O, draw a line at an angle of 2 theta, and from that drop one point. So this point will be the D point. Clear? So in this diagram, if you observe, if I join this C point with this E point, then here I will get angle theta. If I join A with E, then I will get the resultant stress, and this will become a phi, angle of obliquity. And if I measure this A to D, here I will get the normal stress. If I measure E to D, here I will get the tangential stress. So from the third case I can say that if I measure length AE, so AE, then this is nothing but resultant stress on oblique plane. Next A to D, that is normal stress on oblique plane, and ED equal to shear or tangential stress on the oblique plane. Clear? So these were the different conditions. So if you try with analytical also, you will get the same thing. So it is the simplest method to find out the resultant normal shear stress, maximum shear stress. So here we can say this OG, that is equal to OF, that will be the maximum shear stress. Clear? So this is one of the simplest method, graphical method, to evaluate the normal, tangential, principal stress. So in while deriving or while explaining, I have considered the different values also. So similar numerical will be there. Clear? I hope you understand the entire three conditions through which we can evaluate the normal, tangential and maximum shear stress. Thank you.